Hey, good day, everybody. Today we're going to be looking at what happens when waves either run into something that they can't go through or experience some kind of a change in their medium, what they're moving through. And so we're going to see three different reactions to these scenarios, and we call these reactions reflection, refraction, and diffraction. And by the end of this lesson, you should be able to identify and give examples of each one of these things. So let's go ahead and get started. The first one that we're going to be looking at is reflection. So reflection happens when a wave runs into an object that it cannot pass through. Think of like a sound wave in a cave bouncing off of a wall, or a light wave bouncing off of a mirror. We refer to those things as reflection. So if a vertical surface is put in the path of a wave, the waves are reflected from the surface at the same angle that they strike. And what this means is that if I have an incoming wave, like let's say my wave is going this way, and let me switch my colors here so you can see that a little bit better. There we go. So let's say I've got an incoming wave down here, and it runs into this wall. Now what's going to happen is that if I was to measure the angle, and I'm going to draw a little line that shows kind of the middle of things, if I was to measure this angle right here, and I'm going to refer to this as my angle of incidence, or I, is that this wave is going to bounce off at the exact same angle that it hit the wall at. And I'm going to refer to this one as my angle of reflection. That's going to be R. So we get this rule that kind of determines how waves are going to reflect. And we say that our angle of incidence and our angle of reflection are always going to be equal. Our angle of incidence is the angle at which the wave hits the barrier, and our angle of reflection is the angle at which the wave is reflected. And so we've got our incoming wave. This is our angle of incidence, kind of moving from the left to the right. It runs into this object that it cannot go through, and it bounces off at the same angle. And I'm measuring that from a dotted line in the middle, which I'll refer to as a normal line. That'll become important later. So this is the idea of reflection. A good example of reflection would be like a sound wave bouncing off of a wall. You might refer to this as an echo. If you've ever seen somebody say something loudly in a cave or an empty room, something like that, and the sound waves kind of bounce around, that's the idea of an echo. Those sound waves are reflecting off of walls that they cannot pass through. So our second one that we look at is called refraction. And refraction is what happens when the medium that the wave is passing through changes. And this is going to affect the speed that the wave is moving at. So in this top picture, I've got a series of ripples in shallow water that are moving from the left to the right. And there's a shallow piece of plastic that has been put in there, and that's going to make the kind of the depth of the water that the wave is moving through, it's going to be changed from here to here. This is where we're going to have shallow water. And you can see that the pattern in the ripples changes. The ripples here are much closer together. And that's because my wave is changing speed as it passes through this kind of shallow area. In this case, it's slowing down. So this is our effect that we're going to call refraction, and it occurs when the speed of a wave changes, typically because something is changing about the medium that the wave is traveling through. Now, if that change occurs at kind of an angle, or if the surface isn't perfectly level, what you'll see is that one side of the wave starts going more slowly. Think about if you were pushing a box across the floor and one side of the box got kind of hung up on something. Well, that would cause the entire box to start to rotate. The wave is going to do the same thing. So if we have a wave, and I'll use red this time. If we have a wave that is moving from left to right, like we have down here, as soon as this side of the wave starts to drag, the entire wave is going to start changing direction. So it's going to kind of lean into that side where it's getting slower until it clears whatever the change in the medium was, and then it goes back out and it kind of straightens itself out. And so this is the idea of refraction. You've probably seen refraction if you've ever been driving on a hot day and you see kind of the shimmers in the air right above the road. That really hot air is bending the light that is coming through, and that's refraction. Another example of this, and you've probably seen something similar, is if I take like a triangular prism and I shine a light ray through it. Let's say this is my incoming light ray. What comes out on the other side is all the different colors of the rainbow. That's because all those different frequencies of light are being refracted at a slightly different angle. So it creates that nice spread out pattern. So that's refraction, and you're going to see refraction anytime there's either a change in the medium or if you see a change in the direction of a wave, that is also coming from refraction. Now our last one that you're going to have to know is called diffraction. And I know that refraction and diffraction kind of sound similar, but they are different. In diffraction, this is what happens when a wave runs into an obstacle, but there's a gap in it. So as the wave attempts to pass through that aperture or gap, we get this effect called diffraction, and what it looks like is that the wave starts to spread out on the other side. If you take a look at this image over on the left with a very narrow slit in the wall, what happens is once it gets to the other side of that slit, the wave spreads out immediately. You might notice this if you are maybe in your room and all the lights are off and it's dark, but there's a light on in the hallway outside. You can see the light passing in through like the bottom of your door, and then it spreads out as soon as it gets to the other side of that gap. That's diffraction. Now, the weird thing is that a narrow gap produces this very, very wide spread. It gets this nice circular pattern. If I have a wider gap over here on the right, you'll notice that my pattern for spread actually winds up being much more, it's much more focused. It doesn't go everywhere. It kind of just tries to keep going in its sort of a straight direction. And so this is one of those weird things about diffraction, is that the wider the gap gets, the more focused that those waves stay together. This has to do with the kind of the ratio of the gap to the wavelength, but the exact math that you'll need for that is not part of this class. So for right now, just understand that narrower gaps tend to produce wider diffraction patterns, and wider gaps produce more narrow diffraction patterns. Now, one of the tasks that you will have to be able to do with this information is identify kind of images and figure out which effect is happening due to on which image. And so let me give you an example of that. So we're going to drag the title to the appropriate picture. I've got my first one over here. I've got a change in medium. I'm going from deep water to shallow water, and that is also causing a change in direction for the wave. One of the things we talked about did that, and that thing was refraction. So this is an example of refraction. I've got a change in medium and a change in direction. Example number 2, I have a gap in a wall. Looks like there's a doorway, and as the wave passes through that gap, the wave spreads out on the other side. And this is the one that we just talked about. This would be an example of diffraction. And my third and final example is I have a wave running into something that it can't pass through, and so it bounces off. And it bounces off in kind of a very symmetrical pattern because the incoming and outgoing angles are the same. And that is our example for reflection. So if you were to put these all together appropriately, you would get this response right here. Now, as we kind of wrap these notes up, I do know that it was a much shorter kind of section of notes today. What I would like you guys to do is take a highlighter, and I want you to highlight or circle the 5 most important terms or words in the notes. There's 3 that, in my opinion, are obvious to pick, and you really should pick, but I want you to kind of look through and find a couple of additional ones to highlight as well. I will allow you to skip part 2 where you explain to your partner why you selected those words. And then the last thing I would like, after you're done highlighting your notes, is I have a set of summary questions for you. This covers material that was on 10.1 and 10.2, so your wave basics and reflection, refraction, and diffraction. So I'd like you to answer the question, what are the main parts of a wave? So kind of what are the elements of the wave that you should be able to identify? How are frequency and period different? What are two different types of waves? I gave you two specific types of waves in the first section. And then if a wave is changing its speed as the water becomes shallow, which of the three wave changes does this describe? You should be able to answer those 4 questions in your notes today.